Alright, so today we're going to talk about the shell command, the draft, and split. And we'll also throw in thread, just for fun. Right. Did it take over, everybody?
Yeah.
You want an intake? Alright, then look at the screen next to you. So, what do you think shell does? It hollows something out, right? So, like these parts, this is one of your parts for today. It's got the same wall thickness all the way through. And so you draw it solid and into the shell command, and then you can add the ribs back in also. So why do we do shells on things? What kind of parts would need a shell?
Plastic.
Yeah, plastic things that are molded. Because usually those want to have the same thickness all the way through. So you just draw the outside, you shell it, and then you get your thickness. Then you can do any extra changes you need. So injection molded parts, stuff like this, packaging, all kinds of stuff. What about pipes? Is that a shell? Yeah, that's the way I like to do pipes. Draw it solid, shell it. That gives me my thickness of the walls. If you have fillets, it automatically scales them down for the right thickness. So I use shell a lot. If I go to shell, I have a couple options. I most of the time use this top option, where it shells inward from where your model is. You can also have it shell outward. And I've done that a couple times. When do you think you might use that? When would you shell outward from something?
What would that even look like?
So, right now, let me take that face off. If I shelled inward, this was my original line, it came in. If I shell outward, this was my original line now. And so it goes to the outside instead of going inside. See the difference? So why might you shell something to the outside? Yeah, you're making a mold for something. You'd have the part, and you do a shell outside, and I'd make the mold for it. Or you're making a case for something, like for my phone. I made a case I could slide it into for in the car. So I modeled the phone, then I did an outward shell to make the actual case part. So, or you can shell midline. I don't know why you use that one. Because then half it goes out, half goes in. So also here we have remove face. So usually when you're shelling something, you want to remove one face. Because otherwise what happens? You get a ball. You can't see the inside of it. But most of the times you want to have one face open. Yeah, usually you want to have some way to get to the inside of it. So you remove a face, so in this case we'll remove that face. So that way the top will be open. And I want to remove this face too, just so you can see what it looks like. And then here we set the thickness, so I want 1/8 of an inch. That's going to be a thickness of 1/8 inch on the walls. I can say okay. You can see what I get. I could also go in this bottom part, I can make some faces thicker, which in plastics you usually don't want to do. In metal, sometimes you'll want to do it for something, or if you know you're going to be taking extra material off the top side, you might want to do it. So then you can come down and pick the face you want to add material to, or to add that face. Now you can tell that to be a 1/4 inch thick. So you can see that one face, when it shelled it, was made thicker.
You didn't have to pick it, you didn't have to remove a face again?
No, because I just edited that other shell that already had the face.
Oh, that's already had the command in it.
So what if I wanted that edge to be filleted? Can I fillet it now? Let's try it. Did it do anything to the shell? No? I bring it back above the shell, now what happens? Just by bringing it above the shell, now that shell will carry that thickness through. So one of the things I haven't shown you yet is the different ways to look at it. So if we go to view, right here, this visual style. Right now it's on, yours might be on shaded. I usually like to use shaded with edges, so that's so I can see the edges really well. So, like here, unshaded, it's real nice and smooth, but you can't tell where your faces are. So a lot of times I like to work shaded with edges, but sometimes, like I want to see what that's like inside. I go to the visual style, and I can say shaded with hidden edges. So now I can see those hidden edges in there. Or if I just want to go, and you can see as I rotate it, I can see the hidden edges also. Or if I just want to look at a wireframe, I can look at a wireframe. And I can really look at it and see exactly how things are lining up. But usually I stay shaded with edges or shaded with hidden edges. I like those two. They work for most things I need.
Can you still do a command on a wireframe?
Yeah.
Same thing?
You can do anything on any of the views, or any of the visual styles.
Is there a way to do like cutaways so you can see what the exact wall thickness is?
Yeah, so if I was on this, if I sketched here, and I can't really see that sketch, if I hit F7, it does a section on my sketch plane. So that's the way to do it. Yeah, so you create a sketch, hit F7, and then it'll cut it right there. So that's like if you're working on the inside of a part, you've got faces on the sides and you can't really see your sketch, hit F7, it'll cut it. That way you just have one nice thing to work on.
And then once you're done, you finish your sketch, go
Yeah.
back.
Yeah, as soon as you finish the sketch, it'll go back. Go back and edit that sketch. It'll still be full. I have to hit F7 again. But here's the tricky part with this though. Let's say I want to project that edge. I go to project geometry. I can't pick there. Why not? Because there's no edge there, right? We're just cutting our view. So I'd actually go back here, project that edge. Because that's the edge I want projected. And now I could draw on off of that. So if I wanted something sticking up there, now I can draw that piece of it. Okay? So you're working on kind of the inside of something, F7, but then remember you have to look past it and project that edge. Any questions on that? Alright, so that's shell. Next one is draft. This one is a kind of a tricky one to at first. It took me a while to really understand kind of what it was doing. So the first thing you do is you pick an edge. And so whichever edge you pick, that's what it's gonna kind of revolve around. So like if I pick this edge, oh no, see, master being pulled right. I want to pick kind of which way I want it to bend. So I'm going to pick this edge here. Now make it so it'll bend that way. So it's kind of, but now that I'm on face, you can see that now as I'm going around, everything's kind of going off of that, this arrow for the direction. I can flip the direction, so now it's going to go up. Now that face is going to go down. You can see now that wherever I pick, that's the line that's going to hinge. If I pick here, I flip it so it goes up. I pick there, so to go 10 degrees. This line right here is going to stay the same. So if I hold my finger there and I hit OK, that line stayed still, but the rest of the face changed. This part of the face went down, that side went up. So that line that I picked stayed the same. If I did this line, now that line's going to stay the same. And the rest of the face will change. So if you want to add draft to a face, if you're doing a molded part, you can use that and just add draft to that one face. And pick which line you want to stay still, and it'll go. Okay? Questions? No? Alright. The next one is split. So split, can either split faces or split the part. And so we need a sketch. So I'm just going to so I want that wavy cut. I don't want to close my sketch, but I've got it fully constrained and everything. Right? Always fully constrain it, right?
How is that fully constrained?
It's not. I'm imagining.
Oh, okay.
So if I go to split, it asks for the split tool. The split tool could be a sketch, or it could be a plane of something, or a work plane. And next week we'll talk more about the work features and creating new work planes. But right now I'm just going to use this sketch as my feature. And here, this one is split face. So if I go ahead and I split it, my split tool is that. Now this one is going to let me pick which faces I want to split. This one it'll split all the way through the part. Say okay. You can see it split that, but it's all same solid still. Just instead of having one face, now it's two faces. So why might you want to use that?
Maybe for like a two-part mold.
What?
Maybe for like a two-part mold.
Yeah, but then you probably want to cut part of it off. This is really used if you want to go in and do some of the more advanced surface stuff, which we're not going to get into. Because now you can go in here to this face and delete that face right there, and then you can re-sculpt that face and just that part of it, which we're not going to do in here. That's like, I've only done that on one job, and then we threw that out and we're just doing fillets. After I spent like 8 hours on it.
So what's the point of using that to revolve?
Yeah, it's if you want to be able to, instead of having that flat face, if you want to be able to sculpt it and use the surface modeling, then you can take out just part of a face. But using the second part of it, right, if I use this one, now it's actually going to cut the solid. and that's how you can also remove that side. So now it actually cut the solid off. And that one is more common. And so you can use, like I said, you can use planes or anything. So like if you wanted to make an oblique surface, so it's angled on two different faces, you could draw it as a box, set up a work plane to kind of cut the corner, and then use the split just on your work plane and not have to do any sketches. So it kind of saves a step. So like if I wanted to cut the corner of this box off, if I wanted to cut the corner here, off, I'd have to set up a work plane. And so instead of having to then create a sketch and project some points and draw lines, I just tell it to split it using that plane, and it cuts it off. So we'll do that next week. So next week we'll actually use this a little bit to cut stuff off. Okay?
So when you do the split, we can actually remove it, right?
Yep.
From the
you
other
actually
spot.
take half of it off. And you can also do it, and you can leave the whole thing just as two different pieces. But I don't see why I do that. And also, if you look up here under solid bodies, now I have two solids. So I can turn that solid off, or I can turn it on. So now there are actually two different solid pieces that are in the same model, which is again more of an advanced thing. So this is where if you're doing like this, you could do the model all together, and then you'd make your split line, and then you'd split it into two parts. Now each of those can be different parts that you can work on and do drawings of and everything. Okay? Questions on these? I want to talk about threads. So, you know how to do threads for internal holes, right? We just do it in the hole command, right? Just do your hole, you tell it thread it, it makes the threads. But if you want external threads, so if you have a little rod sticking up there that you want to thread it. You can't use the hole command to thread it. So we have the thread command here. So you pick on thread. Then you just pick on the cylindrical face. You can tell it whether you want full length or not. So if I didn't want it full length, I could do that. Make sure you pick the right side. It'll only let you do it on the top. Sometimes though, if you didn't have it connected to something else, it might let you do it on either side, so you can use the flip to make it go to the right side. Then on the specification right here, that's where you can tell it what type of thread to be. And you can see that it knew that that's a 1/2 inch diameter, so it picked the 1/2 inch thread. So now you can come in and tell it which type in here you want. Okay? So if I wanted 1/2-13, I'll leave it on that. Say OK, and it puts it in. And again, that's just a cosmetic thread. It didn't actually make the thread. Okay. How could I actually make the threads?
Coil.
What?
Coil.
Yeah, use coil. So we haven't done that yet, so I'm going to delete that. I just lined it up. Since we haven't talked about creating work planes yet, I just lined this up so I can use this plane as my work plane. And I'll just turn all that to construction. Now I'll project that edge of the cylinder. Now's a good time for that F7, right? So I need to cut into that cylinder. And so if I didn't do that, I drew my tooth. I can't see it. So now I can hit F7. I can see that tooth in there. So what is a tooth supposed to look like? What's a thread supposed to look like? Yeah, so, but the general tooth itself. Sides going to be equal, right? What is that angle in there? 60. Yep, 60. And then what's this distance here? If I want to do it a half 13 thread, what would that distance be? 1/13. You just take the threads per inch, invert it, so you get 1/13. And I'm just going to do a basic thread. I'm not going to, because Darren was right, it should have a flat here, or a flat here and a fillet down there. Actually, I might do that. So, and actually, what I need to do is, if I do this, those points are going to line up exactly, and it's probably going to give me an error. So what I'm going to do is I'm going to tell it minus 0.002. I'm going to subtract 2 thousandths from it. Just so I'm going to have a little bit of a gap there. Actually, maybe just 1 thousandths. So now I have a 2 thousandths flat on the top. And this is where, yeah, I'm just going to spit. I'll add a fillet on the bottom later, because it's just one fillet all the way down. So I'll finish. Now I can do coil. My axis. Uh-oh. I don't have an axis there. So I'm just going to do an axis here. I'm just going to make a quick axis. I'm going to pick on that cylinder. Now I can do coil. That's my axis. I want to revolve going down. Pitch is 1/13. So I tell it pitch and how many revolutions I want. Revolutions and height. Pitch and revolution, or pitch and height. So yeah, that's what I want. Coil shape. I want it to cut. That's that. Oh, see, now I've got this extra solid thing. Why do you think I have that? Because I have 2 solids. If I had to split that into 2 parts, I wouldn't have that solid option right here. And it wouldn't have made me pick it. So I can say, okay, I cut down. It's not really well. Maybe I need to come up a little higher.
How long was it until MK's with your threads? They start halfway on.
Yep. So what I'm just going to do is I'm just going to click on that face, hit sketch, finish it. My sketch is done, right? I want those same edges. So now I'll just do another coil from there. Go the other way. And tell it to cut. So now I probably need to fill it there.
Could you simply just, instead of drawing your triangle inside the metal, draw it above it and then have it do a coil down?
Yeah. I could, if I had started it above it, then I could have done it fine. Yeah. So let's do that. I'm going to go take that split out. Just so that's one less step. that. But this down here is still kind of messed up, so I'd have to fix that. Coil axis. Okay. I can add that taper. See, by doing a taper, it's making it get bigger as it goes. See, now it kind of, it's like they were cutting and they let it out real smoothly. So that top is still messed up, right? That's not how threads look on the top. They don't have that. So how would I fix that? Yeah, chamfer, right? Could I do a chamfer? That's what it needs, but can I do one there? No, won't let me do one there. Because I don't want to chamfer this side. I don't want to chamfer that edge. I want the whole thing to be chamfered, right?
You chamfer it before you thread it?
Yeah, I probably could. Let's see. Yeah, that works. That's probably the easier way. Afterward, I could have also drawn a chamfer and revolve as a cut, but chamfering it first looks really good. So there now I've got an actual model thread, and I can do a little fillet down there. Nope, don't want it. Forgot the point. Now you can see where the big model starts to slow down a little bit. Oh, fuck. There we go. Now I've got my fillet down there. So yeah, now that I add the fillet afterwards, I'm just going to erase that one and redo that. Come on. And tell it to cut. So now I've got good threads on it that I could actually print out and make it screw together. Now you know. Now you see why, if you don't have to, you don't do real threads. Because it's not a simple one-step process. It's a few steps. But if you want to be able to prototype it, 3D print it, you have to do it. If you want to have it machined, you don't have to do it. The cosmetic ones lets the machinist know, okay, I need to tell it to thread this thing. Okay. Questions?
So when you're drawing, you get the machine, you don't really have. You can just do like a standard drawing, and then your details, your detail description will actually tell them
Yeah,
how to
because
do it.
when you do the cosmetic thread on the drawing, it'll put them in right with the hidden lines, and it'll put in a thread call out and everything for you. and so the machinist will see, okay, yeah, that needs threads, and they'll, on this, they're not going to cut that with a lathe, they're going to use a die. They're going to put the die on it, it's done. They're not going to spend time to turn it on a lathe and all that stuff. They're like, oh, that needs threads here, get done. Anything else? I've done my lathe too.
We usually do something like just to get it perfectly centered.
So, any other things? No. All right. So you've got that orange piece as was one of your practice today. Draw it as if it had not been used yet. These have all been used, and so they're all bent. It's a concrete form or something like that. Draw it as if it wasn't bent yet. Okay? I don't know what. That's what I was told. It's got concrete in it, so. Draw it as if it was perfect. And then do the shell and the ribs. So ribs, just draw in rectangle, extrude it down to the next thing, right? Remember to use your different terminations, so use the two. Use all, use two next. Use those terminations for things. Make sure, remember on your sketches, constrain the geometry first so it moves correctly, and then add dimensions to it. Don't start adding dimensions until it's all moving the way you want it to. Okay? Those are the two biggest issues that I saw on people for Lab 1. And if you can, project geometry. Use something that's already there. Okay? Alright, and then the other one is this part here that's in there. Do it a full round. And then down at under here under portfolio. Right here, where's this portfolio project? That has the PDF for this. So you can do that part now. You don't undo that part yet, because the ears, okay? Or that part, so the ears. But the basic shape of it is the same as that, right? So could you do this one and then copy it and to start a starting point for this one? Yeah. Just don't use save as in Inventor. You want to copy it before you open Inventor, use Windows to copy it, rename it, and then open it up. Don't open it and hit save as. If you do that, you won't be able to edit either one of them. Don't do it. Don't use save as in Inventor. If you want to make a copy of something, copy to Windows Explorer, rename it, and then open it and make your changes. Okay? You can do that one. We haven't done the loft yet for that. You could do that. You do that. You do that. This one needs a loft again here. You do that. And don't do the sheet metal one yet until we get to the sheet metal. Yep.
How do we do the data drawing next to it?
Do the models for now. We'll do the in 2 weeks. So next week we'll do work features, and then we'll do the drawings in 2 weeks. It'll make all the views for you. Yeah. So you can do most of the parts now. Or draw my maximum material condition, so where it has the most material in it. So external dimensions need to be big. Internal dimensions like holes and slots and stuff need to be small. And then also, remember I talked about the eye properties? Talked about the eye properties before. You guys remember that? This is where they go. So the part number that we put in the eye properties fills in here in the bill of material, and also here as the drawing number. The title fills in here. The description fills in here, and the stock number right here, stock number, that goes right in to here for the material. So by filling that stuff in the eye properties of the part, it'll automatically fill in the title block when we bring the part in. Okay? So when you're doing this, make sure you get in, fill that out. Also, and the author goes into the drawn by for your name. So make sure you just start filling out those eye properties and start doing it on the practice also, so you kind of get in the hang of it. So title, description, part number, and stock number, and then the author. So those are the 5 things you should fill in. And why do you think we have the description and the title different?
Between the parts.
What?
So you can tell the difference between the parts.
Yeah, and sometimes in the description, in the bill of material, you want to have some extra information that's not in the title of the drawing for it. Alright, questions?
So we put them in a title block already?
No, just do the models for now. When we get to the drawings, then you'll put them in the title blocks. So right now, just start working on the models. Make a project for it. Start putting all the parts in that project. And then when we get to drawings, you can start making the part drawings. And then when you get to assemblies, then you start putting it together. Also, one thing on the tolerances. So, like this one has a tolerance on it. You can do the tolerance in your sketch. If you're here, you right-click on that, go to Dimension Properties, and then go to Tolerance right here, and put it in. Symmetric, whatever that is. Right, you can put your tolerance in here. And then when you do the drawing, you can pull that tolerance straight through to the drawing. You don't have to re-put it in. Or you could wait until the drawing. I prefer to kind of do them here. Why do you think I'd like to do it here in the model first?
Constraint.
Yeah, that's our dimension I'm already going to use, but sometimes I might not use the same dimension, especially if I had to use my geometric ones. But if I do it here, I don't forget about it. I don't forget what that constraint is. So when I'm designing it, oh, I need this tolerance here. I'll put it in there so you don't forget about it. But some of them, you can't do it. So here, I can't put a tolerance on that extrusion height there. I can't do it. And so, if it's a sketch dimension, you can put a dimension or a tolerance on it in the model. But if it's a dimension that's on an extrusion or something, you can't put a tolerance on it here.
So when do you do it?
So you have to do it in the drawing.
In the title block or in the actual drawing?
Well, the drawing is what goes into the title block. So we call this whole thing the drawing.
Yeah.
Okay. So, questions? No?